Earth is a coastal planet. It has 1.6 million kilometers of coastlines. That's about 40 times around the equator. Did you know that 83% of all countries have coastlines? Coastlines in different shapes and forms with different climates and ecosystems. And people like you and me, we are attracted to coasts, especially sandy coasts. Perhaps we like it a bit too much. We like it so much that it has implications for coastal evolution, sometimes with unbalanced benefits. Currently, the coastal population is growing faster than the inland population, and they face increasing challenges such as sea level rise, coastal erosion, and an increased risk of flooding. Coastal dunes, they are one of the most efficient natural barrier systems against flooding. Opposed to sea dikes, they are built by nature, and the disadvantage is, however, that they are very dynamic, and the safety level provided by them varies in time. And here is where my research begins. So my name is Glenn Strypsteen. I'm a PhD student at KU Leuven campus Bruges, and I study the wind-blown sand transport at the Belgian coast. And in today's talk, I'm going to share with you how the Belgian dunes are behaving. So as you all noticed in the past few days, there is a storm raging through Belgium with wind speeds up to 115 kilometers an hour. Those high wind speeds caused a lot of sand transport on the beach. Wind-blown sand transport is a topic that has been investigated by scientists since the beginning of last century, but it's only during the recent years that it has been investigated in coastal areas. Research about how are dunes growing due to those processes is of course very relevant, and often people have no idea how these processes really work. So the Belgian coast, stretching between the borders of France and the Netherlands, is characterized by sandy beaches. It's also divided by 255 coastal sections, defined by unchanging boundaries. And that's also used in my study. So maybe you don't know it, but half of the Belgian coast is protected by coastal dunes, and they range in height between 5 and 30 meters above sea level. And since the 70s, the Belgian government has been monitoring our coastline by taking images from the air, and since 1990 by taking airborne laser data to see how our coast is developing. So from those data we can make elevation plots, difference plots, and we can determine how the coast is changing. But how do our dunes change now? Well, these graphs show dune volume in time for different coastal sections along the Belgian coast. Sure, the dune volume is changing over time, but eventually we can see where it is moving. Some dunes are growing in time, so some dunes are eroding in time. And fitting linear trend lines for all the sections can see if this linear trend is valid for the entire Belgian coast. And we have found that 88% of all the Belgian dunes have a linear model in time. They are represented by a linear model in time. It is observed that for the entire Belgian coast, most dunes are growing in time, and some dunes are eroding in time. We have calculated an average dune growth of 6.2 cubic meters per meter per year, with some longshore variability. You can notice between the Haan and Bredene that we have there the most dune growth, and that is attributed by the creation of a wide beach due to nourishments in the 90s. The dune regions next to France and the Netherlands have a slower dune rate, and some regions do not grow linear in time. For example, the dune region in the Bredene, that is 1 kilometer long, does not grow linear in time because they implemented a concrete wall in front of the dune to prevent it from eroding. That was one of the protection measures in the 80s. And that brings me to the end of my talk. My name was Glenn Strypsteen, and my taking home message for all of you is that the dunes at the Belgian coast are growing. Thank you.